Welcome to the Sangfor Network Secure Training course. In this section, we will explain IPSec VPN and Sangfor VPN. The main objectives of the course are to understand the usage scenarios of VPN, the differences between IPSec VPN and Sangfor VPN, the configuration logic and steps of IPSec VPN and Sangfor VPN, and the configuration in multi-line scenarios. The course is divided into 3 parts. The first part is the product introduction, the second part is the main core functions, and the third part is learning through cases. Now let's move on to the first part of the course. First, let's explain the usage scenario. When you need to use Sangfor VPN to establish a training VPN to meet the security access requirements between multiple sites, this requirement can be achieved by using IPSec VPN or Sangfor VPN. The following will explain the difference between these two VPNs and learn through cases. As you can see from this picture, we can use IPSec VPN or Sangfor VPN to achieve a secure connection between the branch and the headquarters. Of course, we can also use SSL VPN to connect the mobile terminal to the headquarters. This is the main usage scenario of our VPN. Sangfor Network Secure must have IPSec branch authorization to use IPSec VPN. Note that if you are using Sangfor VPN, no authorization is required. When establishing IPSec VPN or Sangfor VPN, the subnets between the branch and the headquarters must not conflict, because we need to use subnets to distinguish which network segments are peers so as to perform VPN routing. Here are 2 different types of VPN types. First of all, Sangfor Network Secure provides 2 different types of VPN. The first is the standard IPSec VPN. The second is Sangfor's private Sangfor VPN, both of which can provide secure VPN connections. Here we can take a look at the difference between these 2 VPNs. Let's first explain IPSec VPN. IPSec itself is an internet security protocol. It is a secure communication protocol cluster based on the network layer and using cryptography. IPSec does not refer to a specific protocol. It is an open protocol cluster. The goal of IPSec design is to provide flexible security services for network layer traffic in IPv4 and IPv6 network environments. IPSec VPN is based on the IPSec protocol suite and implements a secure virtual private network at the IP layer. It ensures the security of upper layer OC protocol data by inserting a predetermined header into the data packet. It is mainly used to protect TCP/UDP, ICMP/IP data packets and tunnel communications. We can look at the security services provided by IPSec. First, it has non-repudiation. At the same time, it has access control, including confidentiality of communications and other security services. Let's introduce IPSec VPN. First, let's introduce the IPSec protocol suite. IPSec protocol cluster. It has 2 working modes, transmission mode and tunnel mode. It has 2 protocols for communication protection, which are encrypted by A or S. IK key exchange has 2 phases, phase 1 and phase 2. We will not introduce the specific working principle of IPSec in detail in the primary course. Implementing IPSec VPN security based on IPSec protocol suite. The process of establishing IPSec VPN begins with phase 1 and phase 2. Phase 1 will perform identity authentication, including the exchange of pre-shared keys and the application of other parameters such as NAT and DPT. After passing phase 1, we will enter phase 2 negotiation. We can have a general understanding of this area. For more details, we recommend that you conduct further inquiries and study through Google. Compared with the standard IPSec VPN, Sangfor VPN has the following advantages. First, it supports non-fixed public IP environments at both ends, has VPN multi-line technology, can achieve load balancing of VPN links, and branch users can connect to the headquarters through the internet. And use tunnel NAT technology to solve the problem of IP segment conflicts in multi-branch networks. If you use Sangfor VPN, it is divided into headquarters and branches. The headquarters provides VPN access services and provides account verification and access control for VPN users. On the headquarters side, we need to configure the WebAgent user branch to connect. Usually, as the server side of the network, we define it as the VPN headquarters, and then the branch will establish a connection with the headquarters to access the headquarters side. Usually, the branch office is used as a VPN branch. At the same time, the VPN module of Sangfor Network Secure, Sangfor VPN, can be used as both the headquarters and the branch. The function of Sangfor VPN WebAgent is to help branches find the headquarters address to establish VPN connection. The format of WebAgent supports the following three methods. The first is to use the IP plus port method. This method is suitable for environments with fixed public IP addresses, that is, when there is a fixed IP address on the headquarters side. Then the second way is 2 IPs plus corresponding ports. This situation is suitable for lines with multiple fixed IPs, which will realize VPN link backup and load balancing by itself. If we do not have a fixed public IP, we can apply for a WebAgent domain name for resolution, such as in the ADSL dial-up scenario. During the Sangfor VPN WebAgent address allocation process, all information will be encrypted using DES during the entire transmission process to ensure its security. When VPN is established, the branch will request the IP address of the headquarters will resolve its IP address, and then the WebAgent server will tell the branch the IP address of the headquarters. After the branch obtains the IP address of the headquarters, it establishes the VPN tunnel to achieve the establishment of VPN. If we have this backup WebAgent, when the main WebAgent cannot be resolved, the backup VPN will parse and transmit it to use the backup WebAgent to communicate and establish VPN. Now, let's introduce the local subnet of Sangfor VPN. IPSec VPN usually captures interesting flows through access control lists, but Sangfor VPN announces the subnet for peer access in the form of local subnets. After filling in the local subnet, it will automatically notify the other end of its local subnet, so that the other end has a route to access the local network segment, thereby achieving data mutual access. Usually, you only need to announce the subnets that need to be released to the peer for access. If the VPN is connected, there is no need to announce it. The tunnel interface of Sangfor VPN is explained here. We define this interface as the VPN data transmission port. It is a virtual interface. The virtual interface is used to send data to the VPN tunnel for VPN communication. So here we can choose the VPN communication port, which will generate a virtual interface of VPN. And all traffic will be encapsulated and communicated from this virtual interface. When you configure the local subnet, it will automatically announce to the other party that these network segments need to go through the VPN interface to pass VPN traffic, so as to communicate with the VPN peer. The three most basic steps in the entire Sangfor VPN establishment process are: first, find the target of VPN establishment. In this case, we use WebAgent to find the headquarters and then verify the identity. The identity verification requires submitting correct and sufficient information. The common verification methods here include account password key, hardware features, third-party verification, etc. After the VPN is successfully established, the corresponding policies, permissions, routes, etc. will be matched, including the allocation of virtual IPs. Therefore, the entire process is a process of addressing, authentication, and matching policies. Here is a brief summary of the differences between the two VPNs. First of all, IPSec VPN uses UDP port 500 and 4500, and the port cannot be modified. However, Sangfor VPN uses TCP or UDP port 4009 by default and supports modification. IPSec VPN does not support NAT in the tunnel, but Sangfor VPN can support NAT in the tunnel. Tunnel NAT is mainly used to solve the scenario where there is an IP subnet conflict between branches. We can use NAT in the tunnel to achieve proxy access, but the subnet of the branch and the headquarters must not conflict. Inter-tunnel routing can be used in VPN scenarios where routing needs to be configured within the tunnel. Sangfor VPN can support inter-tunnel routing. Note that when establishing Sangfor VPN, It does not need any static public IP because it has a web agent mechanism, but it needs to meet a minimum condition, that is, at least one end of the headquarters or branch has a public IP, and it allows dynamic public IP. IPSec VPN is a universal protocol. All devices that support IPSec VPN can be connected. It can also be connected with third-party devices. However, Sangfor VPN is Sangfor's own private protocol, so it is limited to connections between Sangfor's own devices. Now we start to explain the second section, which is the core functions of VPN. First, let's talk about the general configuration of VPN. Here we need to configure the interface and select the interface to use for the VPN tunnel. The second thing we need to do is to configure the address and ISP used for VPN connection and communication. When there are multiple links, it will match the best link based on the ISP address database to achieve the best VPN access experience. If the device is deployed in a single ARM configuration, or if there is a deployment mode through NAT, that is, the device interface itself does not have a real export address configured, then you need to configure the public IP address of the front-end device so that the VPN knows how to select the route. That is, if your VPN is not directly deployed as a gateway, you need to enable this function to achieve the reuse of this link. We can define which links we have in advance. Of course, if it is directly a gateway, the link itself is connected to the VPN, and there is no need to configure and define this link. If it is a single link, we only need to configure one link. If it is a multi-link, we need to define all the links in advance, which interface uses which public IP. If it is a single ARM deployment, usually one interface is configured. We can also define two different public IPs for it and define the operator. It will automatically match the optimal link. Then we can see the configuration of IPSec ports E, P, and N. First of all, we need to introduce several key parameters. Next is the configuration of the other party's IP. If they are all fixed IPs, we will choose static IP. If the IP is not fixed, we can use the domain name and the device will automatically resolve it. Then the pre-shared key on both sides needs to be consistent to successfully hash, otherwise the tunnel negotiation will fail. Here we need to configure the encrypted data stream, that is, the network segment that needs to communicate at both ends of the second stage inbound and outbound tunnels. After the tunnel negotiation is successful, the corresponding VPN tunnel route will be generated, and there is no need to manually add the route. In the advanced options of IKE, the first option is the connection mode. The first phase of negotiation is divided into main mode and aggressive mode. The main mode will have 6 negotiation messages, which is suitable for the situation where the public IPs of both ends are fixed. The aggressive mode will have 3 negotiation messages, which is suitable for the scenario where one end has a dynamic IP. In main mode, it matches the corresponding IPSec configuration according to the peer IP address in the negotiation data packet. Therefore, when the peer device is configured with a dynamic IP, main mode cannot be selected. In the aggressive mode, it interacts based on the identity ID in the negotiation data packet. So when the other end has a dynamic IP, we can choose the aggressive mode to force the connection. Then complete the configuration of other common items. Here we introduce the VPN tunnel keep alive mechanism DPD. DPD is an important means of keeping the tunnel alive. Under normal circumstances, do not enter it and do not turn it off, otherwise the tunnel may be disconnected, resulting in abnormal VPN status. NAT-T requires this function to be enabled in a NAT environment. Since the ESP data packet does not carry a port, NAT cannot forward it, resulting in the tunnel not being established normally. After enabling this function, a UTP header will be added to the ESP data packet using port 4500 to solve the IPSec VPN connection in the NAT scenario. Now, let's talk about the basic configuration of Sangfor VPN. For Sangfor VPN, the branch and mobile terminals need to establish a VPN connection by looking up the address of the headquarters. There are 3 ways to do this. The first is static IP plus port, and the second is domain name plus port. The third method is to apply for WebAgent. On the local subnet, we need to add the network segment that needs to be accessed by the other party, so that he will announce this network segment to the VPN tunnel. The other end knows that these network segments belong to the other end. When accessing these network segments, the traffic of these network segments will be communicated through the VPN tunnel. In Sangfor VPN, the directly connected network segments will be automatically announced without the need to configure them in the local subnet. So here we just need to fill in the network segment that we need to be accessed by the other party. Here you configure the interface used by VPN. It will automatically create a VPN virtual interface and randomly generate an IP address for the user VPN port. You can also customize it, but it cannot conflict with the local internal network. This port is a virtual port used for data encryption, decryption, and routing isolation. Usually, we keep it as default. On the headquarters side, we need to add and create accounts for branches. This operation only needs to be configured on the headquarters side. Here we create the branch username, including its authentication method and its corresponding permissions. Then on the branch side, we need to configure the information for connecting to the headquarters. Here we fill in the account and password information created by the headquarters. Then we choose what protocol we need to communicate through. Generally speaking, we recommend using UDP for connection. Here we need to add the information to create the headquarters. After the configuration is completed, it will try to connect to the headquarters. Tunnel routing is usually used in a scenario where cross-branch access requires additional routing. Its main principle is to configure routing between tunnels and forward data packets to the headquarters and other branches to the VPN port. After the VPN port receives these data packets, it will match them with the corresponding inter-tunnel routing and forward the data. Please note that local subnets take precedence over inter-tunnel routes. Therefore, we prefer to configure the local subnet. Of course, if routing within the tunnel is required between branches or other special situations, we can achieve it through inter-tunnel routing. Now, let's learn by doing through case study. Okay, the first one is a case study of IPSec VPN. We will use the following scenario to learn. The customer wants to use IPSec VPN to communicate between two sites. One end is Sangfor network security, and the other end is a third-party firewall. The Sangfor end is a static public IP, directly connected to the internet. Fortinet uses a DSL dial-up, and the customer hopes to use IPSec VPN for secure communication between the two ends. It should be noted here that dynamic IP requires applying for a domain name for IP resolution. Then we first configure the Sangfor VPN. The specific path is to find the IPSec VPN module under the VPN module. In this module, we must first fill in the corresponding information of the local end. You can take a look at this picture. The second step is to configure the local interested stream, that is, the network segment that the local end needs to be accessed by the other party. Then follow the prompts to further configure other options. For example, configure the connection mode, pre-shared key, including interface information, etc. In the third part, we select the key options of IKE. For specific configuration, you can refer to the specific explanation on the device. When we have completed all the configurations here, we can see the status of the tunnel connection. In the VPN status, we can see that the connection has been successfully established with the other party, so the whole configuration is relatively simple. Now, let's start with the Sangfor VPN case study. The customer wants to use Sangfor VPN for secure communication between two sites. In this scenario, the headquarters is Sangfor VPN, and the branch is also Sangfor VPN. At least one end of the headquarters is a public IP. Once again, Sangfor VPN only requires at least one end to have a public IP, even if it is dynamic. Then we can configure WebAgent at the headquarters. We can choose static IP, domain name or WebAgent according to the actual situation. The default port of Sangfor VPN is 4009. Of course, we can modify it according to the actual situation. Then we need to configure the local subnet. Here, we need to tell the branch which networks should go through the VPN tunnel. In this case, only one directly connected network segment does not need to be configured. If there are other non-directly connected network segments that need to be accessed by the branch offices, they need to be configured in the local subnet. The branch will automatically generate the VPN route to the headquarters subnet. Continue to complete the headquarters configuration, select the VPN interface, and configure the relevant parameters. Usually, we keep the default settings. Then we go to the headquarters to create a user for this branch. This step only needs to be configured on the headquarters side, which is very simple. Create a username for the branch user at the headquarters, including his authentication method. If it is a password, enter the password and confirm the password. The rest can basically remain unchanged. The branch configuration only needs to fill in the connection given by the headquarters and select the connection protocol. If the UDP protocol cannot establish a connection normally, it may be blocked by the operator. We can try to use TCP to connect. Finally, we check whether the VPN status is successfully connected to the headquarters. We can see the corresponding status and other related information here. At the same time, we can also check the VPN tunnel to see which network segments will go through the VPN tunnel. Then the local direct network we just released is 192.168.1.0. Here it will generate such a VPN tunnel. Then when we access 192.168.1.0 from the branch, we will access the headquarters through the VPN tunnel. We can test. First, we ping 192.168.1.10, which is a computer at the headquarters. Okay, then we find that it successfully communicates, which also shows that our VPN with the headquarters is established normally and business access is normal. Okay, that's all for this lesson. Thank you for your study.